Hello, we are going to work on some problems from lesson 2.1. It's all about solving equations. So let's go ahead and get started. If you want to open up your book, that will help you as we go along. I've numbered the problems that I've chosen to work on. So it's always important that you read through the section before you watch my video, because the section in the book actually contains kind of the rules and the steps that I'm going to follow, but that I don't have typed out. So for instance, we are going to solve two types of equations today. One is we're going to solve, they're called linear equations because, for instance, they only have one variable, which in this case it's y, and neither of these variables have an exponent other than just this unsaid one. Okay. The other type of equation that we're going to solve today is going to be equations that have a square in them. So like number 9 here has a square. So we're going to learn strategies to solve both of those. So we're going to start with problem number 1. This is from your book, and the problems begin on page 115. So if you follow the instructions on how to solve a linear equation in one variable, they kind of give you some strategies that you should follow. So we should go ahead and use our distributive property first if we have any parentheses. Then we're going to learn how to eliminate fractions if we have them. And then we're going to combine similar like terms on each side of the equation. Then after that, we're going to go ahead and basically use our order of operations in reverse order. We're going to use the addition property of equality to get all of the variable terms on one side and the constant terms on the other. Then we're going to use the multiplication property of equality to get the variable term by itself. And then we're going to make sure that we check our solution. Okay, so we don't have any parentheses and we don't have any fractions. So what we do have to do is combine similar terms on each side of the equation. So we did that. All of the y's, everything is combined that we can combine on the left, and everything is combined that we can combine on the right. So we're going to use our addition property of equality that says that I'm going to choose to move all my y's to the left because I like to have my variable on the left and y is biggest on the left. So that means I'm going to subtract 2y on the right hand side so that that adds to 0. And then on my right hand side, I'm still left with an 11. And then I have 7y minus 2y is 5y minus 4. I didn't do anything with the constants. And then I'm going to move my constants to the other side. So that's your step 2. We're going to get all the variable terms to one side and all the constants to the other. So I'm going to use my addition property again. And I'm adding 4 so that my subtraction 4, they add to 0 on the left. So we have 5y equals 15. Then I'm going to use my multiplication property that says because I'm multiplying here, I can divide by 5 because I want to solve for y. So I try to make it a practice of solving for or circling the variable that I want to solve for. So if I divide both sides by 5, I get a 1. And so y equals 15 divided by 5 is 3. And then I can check by substituting 3 back into my original equation. So 7 times 3 minus 4 should equal 2 times 3 plus 11. So 21 minus 4, does that equal 6 plus 11? And yes, 17 equals 17. So our solution is y equals 3. Now, question number 3 is an example of where we're starting with fractions, and it really makes our equation much more simple if we can eliminate the fractions up front. So I'm going to multiply by the greatest, or I should say the least common multiple. So 15 is a multiple of 5, and 15 is also a multiple of 3. So I'm going to multiply through by the 15. So I'm going to multiply the first term by 15. I'm going to multiply the second term by 15. And I also have to multiply everything on the second side by 15 as well. So every term has to be multiplied by 15, not just the x term. And that is a -2/5. I want to make sure that everybody knows that. Okay, so when I do that, 15, my 5 cancels into my 15 by 3. So I have 3 times a -2 gives me a -6x. Then my 15 cancels completely with my 15 here, so I have just +2. And then my 3 cancels into my 15 by 5. So 15 divided by 3 is 5 is another way to think about that. So I have 2 times 5 is 10. And so what I did was I eliminated my fractions. So now I'm down to an equation where I have all of my x terms on the left, so I need to get my constants to the right by subtracting 2. Those add to 0. So we have a -6x left equals 10 and a -2 is a +8. And then when I divide by a -6, because I want that to equal 1, x equals a -8/6. That also reduces to -4/3. Okay. So the next one, you can either just work with the decimals as they are, or because they both have 2 decimal places, 0.14 and 0.08, that means if you have 2 decimal places, you could multiply by 100. To eliminate the decimal. So you could multiply each term by 100 if you wanted. That means the right-hand side as well, to eliminate those. So you would multiply by 100, you would get 14x plus 8 times 10,000 minus x equals 120 with 2 more zeros, so it's 122,000. Then we're going to use our distributive property because we have the parentheses. So we have 14x plus 8 times 10,000, so 80,000 minus 8x equals 122,000. Then we're going to gather our x's because they're on the same side, so we're going to add those like terms. So 14x minus 8x is 6x plus the 80,000 equals 122,000. And then we're going to use our addition property that says, because I'm adding 80,000, I'm going to subtract 80,000. So that adds to 0. So I also have to subtract 80,000 on the right. Here's my equals. So I have 6x on the left equals 42,000. Then using my multiplication property, I can divide by 6, because you're always strategically undoing the things that are attached to X. So notice I did not really do anything to the right-hand side, except for what was dictated by the left-hand side, because the left-hand side is where I had that X that I'm trying to solve for. So X equals 7,000. Number 5. Okay. So number 7 is the next one I wanted to look at. It's a good one to look at because we have some parentheses that we should simplify our distributive property first before we start trying to solve for y. And this is a subtraction. So this is all on the left-hand side of the equation. So when we use that distributive property, we said we have 5y plus 10 minus 4y minus 4 equals 3. Then I can combine my like terms. We have 5y minus 4y is just a y. And then plus 10 minus 4 is a plus 6 equals 3. And then we're going to use our addition property that says I'm going to subtract 6 so that those add to 0, because I'm strategically getting rid of my 6 because it's on the same side as y. And subtracting 6, so y equals a negative 3. And you could check your answer by putting a negative 3 back into the equation for where you see y to see if the left-hand side equals the right. So this would be 5 times a negative 1 minus 4 times a negative 2 equals 3. And then you have a negative 5, and that's plus 8 equals 3. And 3 does equal 3. So we are correct. Okay. Number 23. Is nice because we're trying to solve for X. So let's go ahead and circle that. And we're going to get our constants to the right-hand side. So using the addition property to add those to 0. We end up with a negative 4x equals 18. And then we're dividing by negative 4 because we're trying to solve for x. There's what we're circling, negative 18. So those add or divide by each other to get 1. So x equals, and it's a negative 18 fourths. It's fine. You could reduce that to a negative 9 halves if you wanted to. Okay, so those were all equations where x, the equations were all linear equations. Now we're going to look at something different, where we are going to have to use our zero product property. And this is also in the lesson 2.1 on page 112. It says if r times s is equal to 0, this can only be true if and only if either r equals 0 or s equals 0. If either of them equals 0, then our statement is true. R times s equals 0. So for example, right now we have x minus 2 times x plus 3 equals 0. So that means either x minus 2 equals 0, or x plus 3 equals 0, or both. So to make that statement true, that means x equals 2, if we add 2 to both sides, or x equals a negative 3 are the solutions. So if x equals 2, the first binomial becomes 0 and it multiplies to 0. If x is a negative 3, the second binomial adds to 0 and then the whole product multiplies to 0. So either of those will make that statement true. So let's look at number 9 on page 115. Again, it's asking us to solve each of the following equations. So we're trying to solve for x. And so because x has a 2, this x term has a 2 or bigger, we can see that we are going to have to do some factoring before we can try to solve for x. So we're going to factor before we can actually use this zero product property that we learned up above here. And to factor this, we have 3 terms. And our greatest common factor is 1. And because we have 3 terms, there's the possibility of having the 2 binomials. And remember, it's set equal to 0. And so I'm looking for factors of a negative 6 that add to make a negative 5. So we have a negative 1 and 6, 1 and a negative 6, 2 and a negative 3, and a negative 2 and 3. And here are the sums. And we want the negative 5. So this is the magic pair. So we have x plus 1, x minus 6. So either x plus 1 equals 0 or x minus 6 equals 0. And so to get this to be true, x must be a negative 1 or x must be a positive 6. Those are the 2 solutions. Next problem. Okay, so we have an a cubed on the left and an a term on the right. So we're going to do some factoring, but that means we have to get everything to one side so it's equal to 0. Or we can only use that 0 product property up here if it's all equal to 0 from one side. So I'm going to put everything on the left by subtracting 16a. Now I'm going to find my greatest common factor. And 9 and 16 don't have anything in common. We can factor out an a. So we factor out an a. We have 9a squared minus 16 equals 0. And there's 2 terms. So our option is it's a difference, and 9 is the square of 3. So we have 3a squared minus and then 4 squared. So this is a difference of squares. So we have a times, and then our factors are 3a minus 4 and 3a plus 4. It's all equal to 0. So now we have 3. Our product rule actually has 3 products this time. Well, 3 factors. So a, 3a minus 4, and 3a plus 4. So either a equals 0, 3a minus 4 equals 0. And by adding 4, and dividing by 3, A equals a 4/3. Or we have 3A plus 4 equals 0. So if we subtract 4 from both sides and divide by 3, we get a negative 4/3. So we have 3 possibilities for A on this one. And then the last one that we're going to do today is number 37. And we have this squared plus this squared equals 9. So we definitely have to multiply this out. So I'm going to do that on the side over here. We have y plus 3 times y plus 3. So we have y squared plus 3y plus 3y plus 9. So y squared plus 6y plus 9. Y squared plus 6y plus 9 plus this other original y squared equals 9. So I'm going to combine like terms. So we have y squared and y squared. So 2y squared plus 6y and plus 9 equals 9. And everything needs to be equal to 0 if I'm going to use that zero product property because I have a squared. So I'm going to have to do factoring. So have to factor. That's my main strategy here. For 0 product property. Okay, so I'm going to subtract 9 from both sides to get that to 0. And when I do, that 9 cancels out. So we're left with 2y squared plus 6y. So I'm looking for my greatest common factor is a 2. Can divide away from both of those and a y. So if we divide out a 2y from each term, we have y left plus 3 equals 0. So for our zero product property, we have either, I like to remind myself, either 2y equals 0 or y plus 3 equals 0. If we divide by 2, y equals 0. 0 divided by 2 is 0. Or y equals a negative 3 when we subtract 3 from both sides. So y equals 0 or y equals negative 3 are the two solutions. So just to recap, you have to decide if it's a linear or it's called quadratic, which means you just have this x to the 1 term, or you have something with an x squared in it, okay? Then you're basically going to use page 110 strategy, and if it's quadratic, you're going to use the page 112 with a zero product property. And because I am allowing you to have a sheet of notes for the exam for each of your tests, it would probably be good to have the strategy from page 110 on a note sheet and a section for the solving for linear and the page 112 on a spot solving for quadratic. Catch me back for 2.2.